Alright, so like I told you before, I can't be here today because I'm over at the middle school, but I just want to go through, you guys know all of the parts of a circle, at least all of them except for the bottom three so far, just from previous classes or things we've gone over in this class. So you should already have the top part filled in. I'm just going to run through it and then explain the last three. Then we have a short amount of 10.4 notes to go through, and then you're going to work on a practice worksheet for today. So starting with a segment with one endpoint on the center of the circle and the other on the circle. So looking at our circle, one endpoint's at the center and one endpoint is on the circle. An example of this would be what I just highlighted there, segment AB. There's a few other examples you could have had, but that segment, as we know, is called a radius. And a radius just goes from the center of a circle to one point on the circle. Now the next one, we have a segment that passes through the center of the circle with both endpoints on the circle. So both endpoints on the circle and it passes through the center. We know that this one's called the diameter. And you know all of these, you've known all of them for a long time. And that one is segment DF. Now we have an angle with its vertex at the center of the circle. So an angle with this vertex at the center of the circle would be one of these angles here. It sounds just like it is. That is a central angle. An example of that would be angle BAF or angle DAB. Now next we have the shortest arc connecting the two endpoints in a circle. Its measure is less than 180 degrees. Less than 180 degrees, we know that is a minor arc. And there are lots of different examples you could have had from down below. You could have had arc DE, arc FB, arc BC, and there are even more than that though. Then we have the longest arc connecting two endpoints of a circle. It's greater than 180 degrees but less than 360. That's a major arc. And remember that we name these major arcs with three letters. So I could have said arc EDF as one of them. I could have said arc FEC. Again, just like with the minor arcs, there are lots of examples I could have used for that one. Now we have an arc with the endpoints that are on the diameter. So if I know that DF is a diameter, when the endpoints are on the diameter, this is creating a semicircle, and it's exactly 180 degrees. And so again, we name those with three letters, so we could have said arc DEF or arc FCD. All right, an angle whose vertex is on the circle. So an example of this would be this angle here, EDF. We know that when it's on the circle, it's called an inscribed angle. And then the part of the arc that is formed by the inscribed angle, that would be arc EF in this case. It's called an intercepted arc. All right, so right now those are all the ones that we have that we've gone over so far in this class or that you know from previously. Now these last three are new to us. So we have a segment just with two endpoints on a circle. So an example of this is segment EC. Its two endpoints are on the circle. It's not necessarily running through the center like it is with the diameter, but it's on, those endpoints are on the circle. This is called a chord. And this one we said was segment EC. So both endpoints have to be on the circle. We also could say segment DE as an example of a chord. Now a line that intersects a circle at two distinct points and it passes through the circle. So that would be like this line here. It has 2 points that are on the circle and it passes through. It continues on forever after that. That's called a secant. And notice it's a line. So remember, a line goes on forever and ever in each direction. So when I call this line DE, I need to make sure I have a line on top of it with two arrowheads pointing in either direction. And then the last one, we have a line that intersects the point at only one circle. That would be, for example, like this line here. And we call this a tangent. So just like what we talked about in trig, this is a tangent. A tangent line only passes through one point on this circle. So you should all know all of these parts of a circle now. The notes that we're doing today relates to tangent. So go ahead and put this away in a safe place because we're going to be using it later. And pull out your notes, the 10.4 notes. We just have a couple examples at the top. Some examples where you have to identify each segment. So if I have DG, this should be a line up on top. DG, this line right here, it only touches one point on the circle. When it only touches one point on a circle, that is a tangent. BE, notice that BE just touches each end of the circle. Its endpoints are just on the circle, so this is a chord. Segment AF now goes all the way through the circle, and that is a secant. Segment BH has two endpoints that are on the circle, but it also goes through the center, and this is a diameter. And then the last one that we have is CH, and we know it goes just from the center to one endpoint on the circle, so that is a radius. So just again, reviewing the parts of a circle. Now what we're moving on to, the rest of the notes today relate to tangents and some of the property with those tangent lines compared to the circles. So here, if I have a line that is tangent to a circle, so if a line is tangent to a circle, then it is perpendicular to the radius. Remember that perpendicular means that it forms a 90-degree angle. So this example down here says tell whether AB is tangent to circle C. Well, if it is tangent, then it's perpendicular to the radius. So this would be our tangent line AB here. We are looking to see if that is perpendicular to the radius AC. So we're looking to see if that forms a right angle in there. So if it does form a right angle, I have a right triangle. And I know I can verify that something is a right triangle using Pythagorean theorem. So a squared plus b squared equals c squared. So if this side, this part here is 5, the whole thing, or this part is 8, then that means that this whole thing is 13. So in order for me to verify that that is a right angle, I can use Pythagorean theorem. If a squared plus b squared is equal to c squared, then that means it has to be tangent. If it's not equal, then it's not tangent. So I know that my c squared is always the side opposite of the right angle. So in that case, it's going to be 13. So 5 squared plus 12 squared equals 13 squared. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. So now I just compare the two sides to the equal sign. Are they both equal to each other? 25 plus 144 is 169. So since 169 is equal to 169, that means that this is a right angle. So AB is tangent to the circle. All right, so now for this one, we have to find the value of x. Well, x is this whole side here. In order for this to be true, it says all the segments that appear to be tangent are tangent. So that means that this line here is, or that is a right angle if it is a tangent. And so now I have a right triangle. If this whole side is x, I can check to see that this will be a tangent if I can use Pythagorean theorem and prove that both sides of the equal sign are equal to each other. So our hypotenuse is x. So 4 squared plus 8 squared equals x squared. 4 squared is 16. 8 squared is 64. And x squared will just stay x squared. 16 plus 64 is 80, which means that x is the square root of 80. So x is 8.9. All right, so now you have a U-try that I would like you to do. Down here, you're trying to find x. You have that this side's 25. This part 6 is only pointing to the radius, so that means that this part here is also 6. So the whole thing is 12. So make sure you take that into account when you do this problem. So pause this video right here, work on this U-try, and then we'll check it together in a second. All right, so we have, if this side's 12, this side is x, that side is 25. If in order for this to be a tangent, that must be a right angle there, which means that 25 will be my hypotenuse. So 12 squared plus x squared equals 25 squared. 12 squared is 144 plus x squared, and 25 squared is 625. So that leaves me then with x squared equals 481. So x is the square root of 481. So x is 21.93. Okay, and then this very last piece, and we're done with notes for today. So if two tangent lines intersect outside the circle, then they are congruent. So in this example down here, I have two tangents. They're touching the circle at only one point. Those two tangents are meeting at one point outside the circle, so those segments are equal to each other, or they're congruent, so their measurements are equal. So I can just set them equal to each other. 2x plus 13 equals 4x minus 8. And I subtract 2x from both sides. So 13 equals 2x minus 8. Add 8 to both sides. 2x equals 21, and divide by 2 to get that x is 10.5. All right, so if you have questions on this, try to ask the people that are sitting near you, and hopefully they can help you out with any questions that you have. You're going to work on a practice worksheet, and then I'd like for you to do your exit tickets and turn them into the turn and tray, and then you have a worksheet to do for homework tonight. That homework is due on Friday, which is the next time you'll be in class. On Friday we are doing a factoring and quadratic formula review.